Today we will be looking at how to use trigonometry to solve a word problem such as this. So as is essential with any kind of problem that doesn't have the drawing to begin with, we want to read through the original problem and identify any pertinent information, and then we're going to just highlight that right here. So we've got a building that casts a shadow of 22 feet. So that's going to be the first thing that I'm going to draw my attention to, is that the shadow is 22 feet. Second thing that looks important is the angle of elevation, so we know what type of angle we're dealing with, is 72 degrees. And then our goal is to find the height of the building. So lots to glean from that. My suggestion from this point would be to just attempt to draw this out as best you can. Just needs to be a sketch, so nothing perfect. So we will just draw our building represented by this vertical line segment, our shadow represented by the horizontal line segment, and then we will close that up to create this angle of elevation right there. And then we'll assume that the building was built perpendicular to the ground, so we'll put a right angle there. And then we're going to label this information that we gleaned from the prompt. So we've got the shadow itself is 22 feet. Our goal is to find the height, so let's just put a variable there. Let's go x. And then the angle of elevation we knew was 72 degrees. And from that point on, we don't necessarily need to look back at this prompt. We've got all the information that we need right here. So then I would think about, in terms of sine, cosine, and tangent, what we have. So the 72 degrees is our angle. We'll focus on that. And then we'll think about that compared to the 72 degrees, the segment that has x on it isn't touching that angle at all. So we're going to label that as the opposite. The side that has the 22 feet is next to the 72 degrees, which we would label as the adjacent. And then the third side is opposite the right angle, so we would call that the hypotenuse. But since we don't have that, and it's not what we're trying to find, we don't want to label it. So then we might want to remember our saying to recall the three trig functions, so, ka, toa. And we've got opposite and adjacent, so tangent will be the one that we use. So from there, we're going to set up our equation as the tangent of our 72 degree angle equals whatever was opposite, which was x, over whatever was adjacent, which is our 22 feet. And then in this case, like any equation, our goal is to isolate the variable. So we're going to multiply both sides by 22 feet, canceling that out. Perform the same operation on the other side of the equation. And once we have that variable isolated, we can at this point type that expression into a calculator. Now, an important reminder on any model calculator that you're using, make sure that your mode is correctly set to the type of angle measurement that you're working with. In this case, we were given our measurement in degrees. So on this model, TI-34, you can hit mode. Make sure that the flashing is on the DEG for degree. If it's accidentally set to radians, you might get an answer that looks okay, but it's going to be wrong every time. So we've got that correct. And then we just need to type that in. So we're going to do 22 times. And then to get to the trig operators on this calculator, we're going to go with second pi button, and then go down and select the one we want, which is tangent, and then our angle, which was 72 degrees. Good habit to close those parentheses. Hit enter, and we're going to get 67.709, etc. And our problem, something else that might be worth highlighting, does say to give the answer to the nearest foot. So we've got 67.7, which the nearest foot would round up to 68 feet. And that is complete at that point. So if you need to rewatch this, feel free to.